Hello everyone, welcome back. So here's the next problem. So next problem is about implementing a very useful technique called something called nodal analysis to solve a complex network problem. Right? It's from the Kirchhoff's law. Make sure to review the Kirchhoff's current law and Kirchhoff's voltage law from the lecture first. And so I'm going to show you how to solve some complex circuit problem having many current and voltage sources and many resistors, something like that, using a technique called nodal analysis. So nodal analysis uses Kirchhoff's current law, and so the very first thing in nodal analysis, the very first thing you do is first choose your reference ground voltage. So it's already shown here. So this is your ground connection. It's also a reference, right? Ground connection doesn't mean doesn't need to be actual physical ground connected to the ground. Ground, something like ground or reference voltage means. So if you mention the reference ground voltage, ground connection, that means you are measuring all other voltage reference to this ground voltage, 0 volt. So this is 0 volt, right? Ground connection or reference. So in nodal analysis, your first job is to figure out all the unknown voltage, all the unknown nodal voltage. It's called nodal voltage, right? And once you calculate the unknown nodal voltage, then you can find all the currents. So how many unknown voltage, or we call it nodal voltage, you have in this circuit? So just 2. So why 2? One is this, because these are all connected, right? So this is at V2 is one of the unknown voltage. So what's the next unknown nodal voltage? Here, right here, V3, right? So you have only 2 unknown voltage here, V2 and V3. Is this unknown? No, because it's at 15 volts with respect to ground, right? So you have only 2 unknown voltages, V2 and V3, and that's what we're going to find using Kirchhoff's law, right? So let's do that. So that's the technique, right? First choose your reference point, and then after that figure out all the unknown nodal voltage, and then solve the Kirchhoff's current law. So you have 2 unknown nodal voltages, right? V2 and V1. V2 and V2 and V3 are the 2 unknown voltages. So once you find V2 and V3, then you can find all the currents, right, using Ohm's law. So let's first try to figure out V2 and V3. So I'm going to choose, I'm going to use Kirchhoff's current law at the junction V2. So at the junction V2, right, use KCL. So I'm going to just write down the short form. KCL means Kirchhoff's current law at V2, right here. So Kirchhoff's current law simply says at any junction in circuit, it says the total current in, right, the total current entering the junction must be equal to total current going out of the junction, right? The charges, the electrical charges cannot accumulate at any point. So total current entering, as shown in the diagram, is I1, right, is coming in, and all the other current. So you have 2 voltage source here. One is the battery voltage, 15 volt, and what is this? This is the current source, constant current source, right? This symbol is for constant current source. Its job is to deliver constant 1 amp in this example. So this is the voltage source, right? So you have both voltage and current source in this example. So then back to this node. So at node V2, I1 is the only current that is coming in. So everything is going out. So I2 is going, right? Plus I4 is also going. Plus this 1 amp is also going, right? 1 amp. That's it. So what is I1? So I1 can be written as 15 volts, because this node is at 15 volt, positive 15 volt with respect to ground, right? So 15 minus this unknown voltage V2 divided by the 2 ohm, right? So that should be the I1, just Ohm's law. 15 minus V2 divided by the resistance, which is 2 ohms. And keep doing the same thing. What is I2? I2 is V2 minus V3 divided by 3. V2 minus V3 divided by 3. Right? But make sure, depending on the direction of the current that you are given, make sure first to write down all the polarities, positive and negative, right? Positive and negative, because the conventional current always goes from positive side to negative side. Make sure to do that. Plus I4, how do you write down I4? So I4 is I4 right here is V2 minus V3. No, no, I'm sorry. Yeah, I made a mistake here. That should be it. I2 is just V2 minus the reference, which is 0, divided by 5 ohm, right? Plus, what is I4? I4 is that I just wrote V2 minus V3 divided by 3 ohm, right? And plus 1 amp, right? And that's the implementation of Kirchhoff's current law KCL at a nodal junction V2. And you get one equation here in terms of V2 and V3. See, you have two unknowns here, V2 and V3. And combining everything will give you, so I'm just gonna, you can solve this now, right? In terms of V2 and V3, you're just solving the equation, you know. So let's solve this equation. So 15 minus V2 divided by 2 is 15, right? V2 plus V2 minus V3, 15, right? 15, 3 V2 plus 5 V3 minus 5 V, sorry, 5 V2, 5 V3, right? Plus 15. So you just solve whatever way you want. So that's gonna, so if you do that, so I'm just gonna give you the number 1.033 V2 minus 0.333 V3. In terms of, you just need a coefficient, right? So this is, let's say, equation number 1, right? So I have this in terms of the coefficients, right? So you get equation number 1. So solving this equation, just make one equation, your first equation. So just after playing with this, so I'm just gonna directly write down the first equation in terms of V2 and V3. So you will get 1.033 V2 minus 0.333 V3 in decimal place. I just kept in decimal places. So you get one equation, right, in terms of V2 and V3. So remember, you have two unknowns, so you need one more equations, right? It's a two unknown, two equations problem. Then you can solve both unknown voltage V2 and V3. So this is your first equation, which we're going to use later. All right. So that's your first equation. Now you need one more equation to solve these two unknown variables. So then now we're going to do one more technique, right? Now we're going to apply the Kirchhoff's current law at V3, the unknown nodal point V3. So I'm going to apply the same Kirchhoff's current law at V3. So at V3, junction V3, what would be the Kirchhoff's current law? V3, so you have three currents coming, right? Two currents coming, this, and one current going out. So 1 amp, which is the current, plus I4. So I4, 1 amp plus I4 is equal to I3, right? 1 amp plus, what is I4? So I4 is again V2 minus V3 divided by 3 ohms. What is I3? I3 is V3 minus, with respect to this is 0, right? V3 minus 0 divided by its resistance 4 ohms, right? And if you now play with this equation, you get one more equation, and then after simplifying, you can reduce this equation. This is what I got in decimal places. I have reduced in terms of decimal places. Right? 3 V3 is equal to -1, right? So this is your equation number 2. Remember, so you have two equations, two unknown variable type of problem. So 1.033, let me write down the first equation. So that was your equation number 1. And now it's a two unknown equations, and you can solve two equations, right, to solve V2 and V3. And if you have more than two variables, or if you have too many unknown variables, then you can put it in matrix form and use either calculator or any Python programming to solve the unknown. But if you have only two unknowns, then you can easily solve this, right? So solving this, so I want you to solve this. So solving this will get you V2 as 8.39 volt and V3 as 6.507 volts, right? So once you have this unknown voltage, then you can solve all the unknown currents. So let's say I1 is this. It's 15 minus V2 divided by 2, right? So 15 minus V2 divided by the resistance 2 ohms. That's your I1, right? And V2 we have already calculated V2, which is 8.39, and that will give you 3.305. And similarly, you can solve all the unknown currents. So is V2 over 5 ohms, right? And that should give 1.68 amps. So similarly, I3 is V3 over 4, and that's going to give you 1.626 amp. And last one, I4 current. I4 is V2 minus V3 divided by 4 divided by the resistance 3 ohms divided by 3 ohms. Should give you 0.628 amps. So this is how you solve the unknown voltage and unknown current on any given circuit network, right, using nodal analysis.